welcome. This is Safa. In the last video, we saw how chattering and damage accurate and reduce system performance. In this video, we learn a soft switching method, the boundary layer approach, to reduce chattering. Chattering happens when the control switches very rapidly between positive and negative value. This comes from the sign S, a term in the sliding mode controller. This rapid switching can excite unmodeled dynamic and wear out mechanical parts. The idea is simple. Instead of a sharp sign change at S equals 0, we use a saturation function inside a small boundary layer and defined by phi. The control changed smoothly. This reduces the high frequency switching. The saturation function acts like the sine function far from 0, but inside the boundary layer, it's just a straight line from -1 to +1. Let's see this in MATLAB. We'll compare the standard sine-based SMC with the smooth boundary layer version. Okay. Sliding mode control with boundary layer. Okay. Parameters, time, desired trajectory, okay, you can see control law here, simple plant, and finally plot result. Okay, run this code. Blue one, you can see actual system output, and red desired trajectory. As you can see, the output now follows the desired trajectory without rapid oscillations. The saturation inside the boundary layer makes the control smoother. Okay. This method trades a small loss of robustness for much smoother control. In the next video, we'll see other approaches in improved SMC performance. Okay, that's it. Thanks for watching. This is Safa. We're learning together one concept, one line of code at a time.